How are you doing on your tape?
It's funny.
Okay, so I want to talk about the epididymis, vas deferens, and then mention the glands. How much longer do we have? 15 minutes. So this is the testis on this side, epididymis on that side. At first glance, they look similar, very almost identical. At low power, what you want to look for is the amount of connective tissue separating the cross sections in the epididymis versus the amount of connective tissue. These are much closer together, very little interstitial space in comparison to the epididymis. The epithelium of the epididymis is pseudostratified instead of simple columnar. So all of these circles that you're seeing that look like these circles are really the nuclei of the pseudostratified epithelium. So when you look at it at a higher power view, here's the epididymis. Notice you still have a region near the lumen that doesn't have nuclei. You wouldn't have that in the testis. You'd be seeing your late and early spermatids. What appears to be tails of the late spermatids in the low power are actually clumps of very long microvilli, known as stereocilia. If you have sperm, they're going to be in the lumen, okay, as they've moved into the epididymis. Certainly no interstitial cells. Because it is highly coiled, we still see multiple cross sections, all right? But on closer appearance, so on a low power view, you're going to go by the amount of interstitial tissue collagen fibers between the cross sections. A high power view is much easier because you don't see those developing spermatocytes that you would see in the testis. All right. The next structure is the vas deferens. This is just showing pulling sperm from the epididymis for use in vitro fertilization. Obviously, if it's pulled from the head and not from the tail, it's not going to swim to the egg. And this didn't work for a long time. But by accident, a researcher, he was researching something else. He didn't do it accidentally. He intentionally took a very slender pipette that he had drawn up a single spermatozoan into and poked it into the egg. He was studying something else, but that process of poking the egg with the glass pipette stimulated the egg to undergo cell division, and it developed into a normal early embryo. And so this allowed development of the practice of triggering, so for sperm whose tails don't beat but have normal nuclear material, or don't have an acrosome reaction, can directly be injected into the egg. And about 50 to 60% of the time, it will undergo normal mitotic division afterwards. So for those, or for specific genetic diseases that they can screen for, they might select a sperm and just inject one sperm. Not a way to go to get a boy or a girl. A little expensive for that. All right, so the vas deferens, if that is cut, is usually done in this area right here. It can be done by using a scalpel. More popular now is the non-scalpel way, which I would have to watch this because to me they're just tearing the skin, and that's supposed to heal faster than cutting the skin. They basically palpate over the upper portion of the scrotum to feel for the vas, and then use an instrument to basically poke through the skin like a crochet hook and pull out the loop of vas deferens. That doesn't sound very, I'm sure they do a local, but it just doesn't sound, it sounds more damaging than cutting it. But anyway, they pull that out, cut off a 1 to 2 inch segment, fold the edges over, cauterize them, clamp them. There's a variety of ways to do that. And then the natural elasticity, when they let go, just pull themselves back inside. This can sometimes be reversible, same as a tubal ligation. especially if they put a solid plastic tube in the lumen to prevent scar tissue. But if you go to the doctor's office saying, can you give me a reversible vasectomy? They're going to say, sorry. You should plan on this being a permanent procedure. So I was after my husband for years to have a vasectomy. I was tired of being the one responsible for birth control. And he kept putting it off and putting it off and putting it off. And so finally I said, honey, he doesn't like needles. He faints when he donates blood. I said, if you're doing this because you really don't want a vasectomy, I'll shut up about it. That's your decision. But if you're putting it off because you just don't want to go through the blood and the cuts and all that kind of stuff, then I'm going to keep bugging you about it. And a few years later, he showed up with a piece of paper for me to sign, saying that I knew that he was going to have a tubal ligation. I said, what's this? He says, well, I went to a group meeting, and before they do the procedure, you have to sign a form knowing that I am going to have a vasectomy. And I said, you're going to be kidding. My daughter can go have an abortion, and I know nothing about it, and I have to sign a paper for you to have a vasectomy? That just didn't make any sense. But anyway, he had it. He had always said he and his best friend were going to go and hold hands and have the ice packs on their scrotum and all that kind of stuff. Yeah, really. And so you're not supposed to have intercourse until they check and make sure, without protection, that the ejaculate is without sperm. And then they check it again 4 to 6 months after that. He never went back for the second checkup, but we don't have any more kids, so I assume. It can go back. There are probably the multiple divorces back in the 80s before DNA testing was available for paternity tests. And the guy would have a vasectomy and his wife would get pregnant. And he'd say, you've been sleeping around on me. And she swore she hadn't. And he said, well, I have a vasectomy. And there was no way to prove genetically that it was his child. And you know, there's issues of trust and all that kind of stuff in there. But obviously now with DNA testing, you can show that it really was, or really wasn't. So the vas deferens is really just a tube that transports the sperm. And if we look at the posterior view of the bladder, similar to this model that's over here on the counter, this is what we see. Okay? So here is the vas deferens ductus being the same thing. As it comes along the posterior wall of the bladder, medial to the tube carrying the urine, it dilates. And that dilation is known as the ampulla. Okay? An ampule is like a glass vial of medicine. And it joins with another gland that releases much of the volume. So here would be the ampulla. Here would be the seminal vesicle, or you may say seminal gland. Sorry, JP, that's going to be another source of frustration. And the two of them form a single ejaculatory duct. So ampulla of the vas deferens seminal vesicle.
Is the ductus deferens the same thing as the vas deferens?
Yes. An ejaculatory duct is a pathway for the combination of both structures. On our models, you won't be able to see the ejaculatory duct unless it's in a sagittal section, passing through the prostate gland. So here's the seminal vesicle, and this structure right here is the ejaculatory duct. The seminal vesicle, there's a list of its secretions on page 74. So this provides the source of fuel, the fructose and the citric acid for the mitochondria to make ATP. It provides chemicals that neutralize the acidic pH It's in the urethra and in the female reproductive tract, the bicarbonate ions. And it also contains a clotting and clot breakdown. So those of you that are familiar with ejaculate, either your own or someone else's, it thickens after ejaculation. All right, and during that time, if it's in the female reproductive tract, the sperm becomes directed in the same, rather than every which way, they all swim in the same direction. And then the clot of ejaculate is broken down by the fibrinolysin, and that would be difficult to swim in if you've ever tried to swim in jello. Not being a sperm, that's what I would have to imagine it as. And then that becomes liquefied, and now the sperm can move on in the reproductive tract. So it helps to orientate the sperm in a similar direction. So the ejaculatory duct is going to empty into the urethra as it passes through this gland. And this is the prostate. So the prostate gland is, I'm almost done, Gretchen. The prostate gland is a walnut-sized, donut-shaped organ that is hollow in the center where the urine is going to pass through. And we would have the two ejaculatory ducts emptying into that. In addition, there are multiple tiny little openings for the prostatic ducts, which are found all around it. Yeah, this is the prostate itself right here, but you can't see the openings in the urethra. Okay, so on this model, this would be a seminal vesicle, and let me just take the top off, it'd be easier to hold for you guys. So this would be the seminal vesicle, and this structure here is the prostate, okay, with the urethra passing through the center. So the fluids and the sperm would pass into that space. The prostate gland secretions are more milky, but they also contribute to raising alkaline, make the lining of the urethra less acidic. So I'm going to finish here by just showing you the histology, and then we'll break for that. So here's the histology of the seminal vesicle. It looks like a maze. When we get to reproductive, this looks very similar to this. In the seminal vesicle, though, if you get stuck in here, there's no way out. Just find yourself stuck in a little room. Over here, I can eventually find my way out into the lumen of the oviduct. Okay? The oviduct is what the egg travels through to get to the uterus. So even though they look similar, when you take a closer look at it, obviously, right now we're not doing females. You'll have to be able to do that. Prostate looks somewhat similar, but a lot more of the tissue around it. And when you look up close, these cells are filled with that milky white substance. Okay? So there's slides out there during lab just practicing identifying it as the organ. All right, let's stop there.